Hello, everyone. I had someone request that I go over question 12 in section 3.3. I've got it right here. I figured we'd go over it together. So the idea here is that you have a rectangle, and the base of it is inscribed along the x-axis, and then the upper corners both lie on a parabola. In this case, the parabola is 9 minus x squared. For each of you, this value will be a little bit different, but always be something minus x squared. Okay, so if we were to start this out, let's call this f of x. Then in my case, I have 9 minus x squared there. So it looks like this. Okay, and the idea here is that we are going to create a rectangle off of this, where if you can imagine the point that I'm holding right now, if that is going to go to the right to its respective corner over here, and that's going to create the top of the rectangle. So that's going to be the base, and the height of it is going to be from this point down. Okay, so so the height of it is going to be my f of x, and the base of it is going to be, well, half of it would be the length for our input x, but since we have two of them, since we are going the same distance on both sides of the x-axis, this means our base is going to be equal to double whatever our x value is. And our height will simply be the output for it, so some f of x there. So if we were to create a rectangle here, we know that that rectangle is going to be, the area of it is going to be the base times the height. Then what that means is the area function is going to be our base, some 2x, times our function, our height of it, which is going to be 9 minus x squared there. So, so this is what we need to look at. And again, I want to make sure I push this idea of a function because it's critical to this course. And it's just assumed that you just kind of understand it after this course. So I want to make sure that when we get an applied question like this, that we understand what it is, because I get that we have a geometry formula here, which is just the base times the height, but the area in terms of a function means that for whatever input, whatever value we choose for x, we are then going to get the area from it by figuring out what this 2x times 9 minus x squared is. Now, I can simplify this a little bit. So I can distribute this 2x here through, and what that'll do is that'll make that 2x be multiplied by 9, so that's going to turn that into 18x. And then that 2x times this x squared here means I'm going to get negative 2x cubed. Okay, so my area function, whether I look at it from this perspective or from this other perspective here, is going to give me the same kind of thing. I'm going to make it a distinct color here. Whereas again, my x values are going to be the length that I choose, or how far away from the vertical axis I'm going. It's going to be what half of that base is, because the base is going to be 2x there. Okay, so notice that what I get out of this is a cubic function, and that if I were to look at my inputs here, I don't really care about the negative values from it, right? So the values for x are going to be the half of the length you choose for the base of it. So I wouldn't practically say, oh, well, the corner of this rectangle is negative 3 feet. I wouldn't do that. So it makes sense that I'm limited by how this thing is constructed, and that there is going to be this kind of natural limits to it. So our domain for this, as you can see, if I were to choose x to be 0, well, then that means that the area of this would be 0, because I essentially do not have a base, right? I didn't go any way over that way. If I choose 3, well then I've got all line off of here, right? I'm like all base and no height there. Okay, so my domain is going to be restricted from 0 to 3 there. And anything between 0 and 3, you can see has this kind of symmetric relationship to it. So if we were to go right in between to this 1.732, this is our input. This is our x value for our function. So this 1.732 is going to get us to 20.785. So let me write that down in terms of a function. So if I were to put in 1.732, what I end up getting out of this is 20.785. Now, hopefully you're not rushing off and thinking, oh, well, that's it, right? That's like the first answer and the second answer. That's, I think, the next confusing part about this. Because what the question's asking us is, what is the width of the box? What is the entire width? And what is the height of it? Well, if we go back to this, this is our x value, right? So a of x, our inputs are this thing. Our total area is going to be this. So when we pick the distance from x to be this 1.732, we end up with the maximum area of 20.785. But if I need to figure out what the base is, well then what I need to do is I need to figure this thing out, right? So my base is going to be double this. So I need to figure out for my base, that is essentially going to be 2 times 1.732. So in this case, I've got, for my base, 3.464. My height is going to be f of x. So I need to put this through f of x. So when I put this into my f of x here, I'll go ahead and drag it down so that way we can see it. When I put this 1.732 in for x here, well then that's going to give me the height of it, right? That's going to get me to the upper corner of this thing. So my base is going to be double this, 3.464, and my height is going to be this 6.000176. So if I go in here, what I need, here comes the moment of truth, 3.464, and then 6.000. I'm going to try it there to see if that's sufficient to get it done. But that's what it's asking you to do. If I go in further, I bet you it'll, oh no, it just rounds it to the nearest whole number there. Whereas this just keeps on moving along with it. It's a tricky problem. Again, setting up a visual for it would be good. This would be an ideal question for me to go over in a face-to-face class where I could actually draw it up and then kind of draw the rectangle so you could see where each of those pieces are. By all means, if you have any questions, I'm more than happy to meet with any of you. I hope that this was helpful, and more importantly, I hope you're all well. All right, have a good day, and please let me know if there are any more questions. Bye-bye.